This is a simplified version of a current flowing into the plane in between the magnetic field north and south. Now here I'll explain to you the direction in which the conductor will move when it's placed in between the magnetic field. Now before I establish that, we have to know the direction of magnetic field around the current and between the magnets. Now to identify the magnetic field around the current, if you recall, we need to use the right hand grip rule. Now just to recap, your right hand grip rule, your right hand, thumbs up, grip the four fingers. So the thumb follows the direction of the current, and you can see the fingers form some sort of a circular shape, and that follows the direction of the magnetic field. The tip of the finger is actually the direction of the magnetic field. So when I want to point the thumb and the fingers in this fashion, we can say that the current is coming out of the plane and the magnetic field is in the anti-clockwise direction. Now if you look at this diagram, the current is actually flowing into the plane. So we still use the right hand grip rule, but this time round we point the thumb into the plane. And when that happens, the direction of magnetic field is now clockwise. So just to keep the diagram simple, I'm just going to draw one magnetic field line around the current. So just one magnetic field lines. Now how about the north and south? Now direction of magnetic field line is from north to south. So this will be the direction of magnetic field lines. Now we are not going to draw any magnetic field line at the bottom because I'm just going to draw one for illustration purpose. If I draw in this way, you realize that the magnetic field lines at the bottom cancel each other out. So I'm just going to ignore the magnetic field lines at the bottom. And therefore, in this case, there's a higher concentration of magnetic field lines above the wire than below the wire. A higher concentration of magnetic field lines above the wire. So that means the magnetic strength above the wire is actually stronger than below the wire. I say again, the magnetic strength above the wire is now stronger than the magnetic strength below the wire. Hence, the resultant force is downwards. So that will be the motion of conductor. So that's the motion of conductor. Now whatever I said all this while is an explanation of how the conductor will move. Now there's an easier way out, and using this I'm going to show you what we call a Fleming left-hand rule. Right, a Fleming left-hand rule. So what's a Fleming left-hand rule? For a start, hold your left fist. Okay. Now stick out the thumb. The thumb refers to the direction of motion of the conductor. The thumb refers to the direction of motion of the conductor. So the tip of the thumb is pointing in the direction of the motion. and stick out your index finger. So here we kind of like looks like kind of shape of a gun where we play when you're children. Right, the index finger points in the direction of the magnetic field. Say again, the index finger points in the direction of the magnetic field. And this magnetic field refers to the magnetic field of the north and the south pole, not the magnetic field of around the conductor. It's the direction of magnetic field of the north to south pole. So the index finger is straight. So that means we can only use this to point in the direction of a straight magnetic field line, not the curved one, the straight one. Next, your middle finger, stick it out in this fashion. Now, make sure the index finger and the middle finger forms a right angle, and the middle finger and the thumb also forms a right angle. So in a way, your thumb, your index finger, and your middle finger, they're all right angles to each other. And your middle finger is pointing in the direction of the conventional current. So middle finger points in the direction of conventional current, index finger points in the direction of the magnetic field, and your thumb points in the direction of the motion of the conductor. So when we come back to this question, we place a conductor in a magnetic field. We want to know how the conductor will move. So the very first thing we do is to align the current and the magnetic field. Align the current and the magnetic field, and then you can determine the direction of motion. First of all, just let you to know that the first time you're doing this, there's a possibility that you may have to stand up and orientate your hand accordingly to solve the problem, or alternatively you can just turn your worksheet or your textbook. It's alright for the first time, but eventually when you gain more experience, you should be able to do it while sitting down. So for a start, you can just stand up or orientate your book. So for the purpose of this video, I already fixed the paper onto the table, so I'm not going to orientate the paper. First, Fleming left hand rule, thumb, index finger, middle finger. North to south, index finger, north to south. Conductor, current flowing into the plane. Now note, I already aligned it this way. So now I have to align the middle finger into the plane. Now take note, I'm not going to change the orientation of this index finger. I'm going to keep it from north to south, so I have to rotate the wrist, keep it in the same direction, with the middle finger pointing into the plane, and look at the direction of my thumb is now downwards, and that's the motion of the conductor. Okay, again, that's the motion of the conductor. Right. So I'm going to repeat again. Index finger north to south. Now you want to point the middle finger in the direction of the current. Careful not to change the direction of the magnetic field. Slowly orientate, slowly, and then you get the direction or the motion of the conductor. So that's your Fleming left hand rule. Final thing to note before I end this video, Fleming left hand rule again. Stick out the thumb first, you stick out the index finger. Now this is a word of caution to many students because they tend to stick the wrong finger out, right? Now, the last finger, which is your middle finger, stick it perpendicular. The common mistake by many students is they tend to orientate it this way, right? No. That's why when I give the illustration, stick out the thumb first, index finger, and I say again, this is a very common sign where you like to play guns when you were children, and then stick out the middle finger. In that way, you won't make the mistake.